All right, so remember that atoms have a neutral charge. That means that the proton number and the electron number are the same. Because remember, protons are positive, electrons are negative. So if you have the same amount of positive charges as you do negative charges, then they're going to cancel each other out, right? So an example right here, helium, right? He is helium. Helium has two protons and it has two electrons. And because the charges are the same, two and two, that means that they cancel each other out. Right. The charges will cancel each other out, and the overall charge is going to be zero or neutral because there is no positive charge, there is no negative charge. They canceled each other out. Right. But if this one had more electrons right here than protons, then in this case, you would have had two protons, and let's just make up this number. We would have had three electrons. So, not a very good three. Um, Actually, let me just write this right here. So, you have two protons, and you have three electrons, right? What that's going to say is that because you have, sorry, should still be a two, that because you have one more electron than a proton, remember, electron, their charge is negative, right? So if you have more negative things than positive things, then this thing is going to have an overall charge of -1, right? Because you have one more negative electron than you do positive protons. Right. So just remember that. If the opposite were true, though, of like in this case right here, let's say that you had two protons, but let's say you only had one electron. Right. And remember, electrons are negative, right? The charge right here is negative. So this right here would mean that it would have been positive by how many? By one, right? So one, and you put a little plus sign. Oops. So this would overall be a positive charge because there are more positive protons than there are negative electrons, right? It's all about which you have more of. So if you have more positive things, overall the atom's going to be positive. If it has more negative electrons, then overall the atom is going to be negative. Right, so in this case, how many electrons does carbon have? I remember what I said earlier about the atomic number, the proton number, and the electron number. And so we've already kind of talked about this and why they're laid out on the periodic table the way they are. And remember here, you see the first period. Again, remember that the period is going to be the horizontal one, right? So in this case right here, this horizontal part. And so you see that in this case, helium and hydrogen, they are both in the first period in the first row because they only have one shell, right? Lithium, carbon, and neon, they are in the second period because they have one, two shells. These are in the third period because again they have one, two, three shells, right? That's why they're laid out in the periods that they're in. Remember, the columns or the groups that we talked about, it's just how many electrons they have on the outer shell. So in this case right here, atoms want their shells to be full. And we've talked about that before. I kind of introduced it earlier, the octet rule, right? So remember that all atoms want to have in their first shell a maximum of two, and in all the other shells after that, a maximum of eight.